Okay, so actually, I was just checking with the recording portion. So let's get started. I'm sharing a tab which will deals with the object detection. Okay, so first let me explain you about the object detection. What does an object detection means? Please let me know if my screen is visible to all. Okay, so our project is related to the object detection, and we are performing deep learning technique to perform the object detection. Okay, so here computer vision plays an important role, and we perform different techniques like image classification and related to it, there are certain other techniques like object recognition. Okay, object localization, object detection. Okay, so these all deals with your part of computer vision. So if you talk about image classification, that means in an image we are available with different kind of objects or something which we are looking forward for, that okay, this image is related to this entity, this image is related to this entity. For example, if you are working with the brain tumor, so if we are having available with the images related to the tumors and non-tumors, so we are going to classify, okay, these images are having tumors, these images are having non-tumors. We are already available with the deep learning algorithms. We train our model on the basis of that, and then we are going to perform the classification. Okay, and if we talk about object recognition, that is what exactly present in that particular image. Okay, that is called as object recognition. So object recognition basically refers to the collection of related tasks, that means identify the objects in digital photographs. Okay, and this technique is been utilizing same for image classification also, for object recognition also, or for any other thing related to images. We are going to perform the deep learning techniques, and this involves convolution neural network, CNN. So from the previous sessions also, I did continuously doing the sessions on images, and I'm using CNN model, my CNN model, because this is only thing where you get an image. Okay, and then you perform the images. Okay, you perform your max pooling, min pooling, flattening, and different other layers are present, dense layers are present. Okay, so every time you perform certain task on the images, okay, you collect the information from them, and then you train your model accordingly. Okay, so CNN, convolution neural network, this is something which plays a biggest role in performing these kind of activities. Okay, so either I can say CNN and RCNN, and there are various other uh, it's a complete family of techniques basically. Okay, and the researchers are working on these techniques, and there every time there are some modifications, or we are going to get some new research papers. Okay, and YOLO, you only look once, is again, it's a second family, it's a second family of such kind of techniques only. Okay, where we are going to perform object recognition designed for speed and real time use actually. Okay, designed for speed and real time. Okay, so basically if you talk about CNN and all these deep learning techniques, you submit your images, you train your model on the basis of images. Okay, that means all those static images and all such things, and you, okay, you get your model trained, and afterward words you can give image to your model. Okay, and then you can detect, okay, whether it is having a brain tumor or non-brain tumor whatsoever. So here basically the CNN and its associated techniques plays important role. Okay, however, if you talk about YOLO, you only look once, they also perform the object recognition. Okay, they also perform the same technique of object recognition. However, here the speed, efficiency, real time analysis has been done. Okay, so let's get started. Object recognition generally means a collection of related computer vision tasks that is used to identify the objects. Okay, so basically, here in this project also, we are going to identify the objects. Okay, for example, if you are having an image that consists of, you have already seen these articles, these kind of shared content where you are having dog and cat, and there are bounding boxes over dog and cat, and they are saying, okay, this is dog, this is cat. Okay, and there are certain different libraries also which are claiming that we are going to predict the objects which are present in the images. Okay, so this is called actually a part of a computer vision, and it's a you know an object recognition technique. Okay, in object recognition we follow image classification. Okay, what happens in an image classification? An image with a single object such as a photograph, we give it as an output, we give image as an input. Okay, and we get a class label. That means we got a tag. Okay, this image is like for example I told, this image is a of brain is a brain tumor. Okay, or either it is a not brain tumor, so we get a tag related to it. Then the next one is the object localization. Object localization, what is it? It is used to locate the presence of objects in an image, whether these objects are present in an image or not. Okay, and indicate their location with a bounding box. Okay, then what does this means? That means we are tagging. Okay, this is the object, this is present, and we are recognizing it with the help of a bounding box. Okay, for example, this is cat, just make a bounding box on a cat and write it there, cat. Make a bounding box on a dog, then just write it there, it is a dog. Okay, so this is localization, locating an object in an image. Okay, so classification is something different. That means classifying the images, okay, yes or no whatsoever. Localization is tagging something, okay, and making a bounding box. Object detection, that means again this is just similar to the localization itself, but what does it say? Locate the presence of objects with a bounding box and type or the classes of the located object in an image. Okay, that means you are also going to mention the type or the classes of the located object. Okay, so here we are going to just locate. Okay, and here we are going to make sure that what are the class of that particular object. That means here also again the same thing, we are going to give an input of an image with different kinds of objects or different entities present in the photograph, and the output is again we are getting the bounding boxes over it, and also we are getting a class label for each bounding box. Labels we will be going to assign here. Okay, now the labels could be like something, for example, if I detect that this is a cat or this is a dog, and here in labels will either mention cat, dog, or also there are certain accuracy or efficiency related to the algorithm which you are using also been mentioned. Okay, for example, point 0.8, point 0.9, point 0.6, point 0.7, because you have seen. So in case of YOLO, we are going to have this efficiency, that means the detection which the algorithm has done, how much efficient it has been in detecting the object which you are looking for in that particular image. Okay, so this is certainly an a flow chart which has been performing the task related to the object recognition. Here the object recognition, it comprises of image classification and object localization. In image classification we detect the object, okay, and object segmentation has been performed. Object recognition, okay, of course it is object localization also, because we need to find that this object is present here or not. We perform the detection, and again we are going to have the object segmentation. Okay, so this is how somehow what these techniques are related to each other. Okay, so you have seen many of the project there where you need to perform image classification, object detection. Okay, these are correlated with each other in form of the techniques which are being followed. Okay, so if I talk about image classification, here there are certain algorithms which categorize the objects which are present in the image. Okay, categorization, classification. Single object localization means in an image, if there are multiple objects, we are going to detect, there are algorithms we are going to detect, okay, this object is present in that image or not. That is called a single object localization. Object detection means there are algorithms which are producing a list of object categories. Okay, that is there, it doesn't mean that there is only single object we are looking forward for. We will list out whatever the objects which are present, we'll list out everything. Dog is also there, cat is also there, car is also there, bus is also there, truck is also there, people is also there. Just list out all these entities which are present in that particular image. So this comes under object detection. We are going to perform, so these are certainly the images which are explaining the concept. Okay, for example, single object detection, we are looking for the drums which are present in the images, so there is a bounding boxes created on the drums, that is they have been recognized. Okay, here also accuracy has been mentioned if you're just talking about other objects which are present in the images are folding chair, steel drum, picket fence, cat, and loudspeaker, and all these things. Okay. Next is the object detection. That means we are detecting what actually the object is. That is person, steel drum, microphone, folding chair. Okay, and also things along with the some accuracy levels also. Okay, 1.0, 1.01, here it is 0.8, 0.9, 0.5. That is, these are certain levels which are been present in your detection. So object detection. So basically YOLOs follows this technique where you can see that their object has been detected, bounding box has been created, and you are getting some points like accuracy is zero point 0.9, zero point 0.4, zero point 0.5. This is the accuracy with which they are sure that, okay, what are the object which you are looking for has been present in this particular image, or either it has been present in that particular video. Okay, this is how the performance of the model image classification has been evaluated. Okay, so there are certain algorithms. For example, I already told CNN, convolution neural network, RCNN. Okay, that is region based convolution neural network. Okay, this is the basic diagram of CNN. And in the previous lectures also I did explain each and everything about the CNN. How does it work? You give an input image, and then there will be the extraction of the features from the image. Then those then with the help of in pooling technique, we extract the features. Then we perform layering. That means dense layers uh, has been used, flattening has been used to look out for the reduction of the matrix into either column major or either in a row major. So this is all the technique performed during the with images, image processing. Okay, so input image, extraction, computation of the features, and performing the classification, whether what kind of image it is. Okay, so what here you used to give, okay, you give an image. Okay, and your deep learning model, this is CNN, this deep learning model, it performs training, okay, over the image. Okay, and you did mention in the image, okay, this image is like this. Okay, it performs training over it and understand by what kind of features have been available in this image. Let me get trained, okay, with these features. Next time if you input the similar kind of image, or what different kind of whatever you will input, I will classify, okay, this is that and this is that. Okay, so this is the task being performed over it. This is RCNN, faster RCNN. So there are various this CNN comprises of the family of these algorithms. Similarly, we are having YOLO model family also. YOLO, you only look once. And today we are going to implement version 7. Actually, YOLO 1, 2, 3, 4, 5, 6, 7 are already available in the market. And the only difference which has been asked to me here in the comment section also, sir, what is the difference? The difference has been related to the accuracy. How much efficient your model has been working in detecting the object. This is the difference. Okay, and obviously, why this difference occurred? The reason is algorithms which we are using. Okay, every time when a new version come up, you have improved the technique, you have improved the algorithm. Ultimately, you are moving towards the faster algorithms, the efficient algorithms. This is what the point is. Okay, and how you achieve the accuracy, how you achieve the fastness, the point is how you have changed the architecture of the model. Okay, because in architecture you might be present certain layers. Okay, so how many convolution layers are present, how many dense layers are present. Okay, how many flattening layers are present. Intermediately, what are other tasks you are performing over it? Are you using some other integration technique also in that algorithm? So no, this all makes a change. Once you are get with the change, a new model has been developed, and after training, testing over those models, you release it in the market. Okay, so there are various models available for the YOLO. Okay, and previously what it happened is, till YOLO 6, it has been shared, or I just say the authorization of till YOLO 6 was ultralytics. So in GitHub, if you just check out how we are going to include YOLO 5, YOLO 3, and say all 6, all such things, you know, ultralytics is the responsible. ultralytics, you can check out in your Google, ultralytics. So ultralytics is something who has developed that in GitHub. It has been available. They are the authorization of that particular model. Okay. And here what happens in these kind of libraries, we are not going to install, we are going to create the clone of these libraries. The reason for cloning is, every time when there are some updation, every time if there are some changes, so the changes are going to get reflected. It doesn't mean that we are just installed with the library and we are up with that. No, we are going to clone this library. We are not going to like write like this pipe install YOLO. No, nothing will be done like this. We are going to clone these libraries. Okay. So the fact is, YOLO model was discovered in 15. Again, there is a paper, research paper. Okay. So everything which has been coming here is based upon the research publications. You only look once, a paper entitled 2015 Unified Real-Time Object Detection by Ross. Okay, developed RCNN model. Okay, RCNN model has been used here. Okay, so RCNN model has been used here. Okay, and approach was like a single neural network trained and end to take a photograph and input and predict the bounding boxes. This was the task performed with the initial YOLO. And later on, the next versions has been getting updated and updated with the architectures. So this is initially something like that, your complete image, which you will give, your digital image, which you will give as an input, it will be, um, it will be like in a grid format. That means rows and columns, it will be just recognized in this particular form of a grids. Later on the basis of your architecture, on the basis of your algorithm, what you need to recognize the bounding boxes and the confidence level. Okay, so whatever you are going to see now, that is the confidence. That means your algorithm is 100 or 80 or 90 or 70% confident that this particular object which you are looking for is been available in the image. So here, later on, what happens is, this is your input image. Okay, it has been distributed in a form of a grid. Okay. And here, with the help of an algorithm, you can see that there is a dog inside it, there's a bicycle here, there's a car which has been standing outside. So the bounding boxes has been created over it. Okay. And along with that, plus confidence level. Okay, that we are confident that these objects are present in this image. And finally, you are getting the detections. Okay. So this is a class or the probability mapping with these two. That means, with the image there is the bounding boxes plus confidence, and the class probability mapping, and the finally you are getting the detections over it. Okay, so this is what happens in a YOLO thing. Okay. So later on, YOLO 2 version, and that's it, which has been available here. Okay. So again, here in case of architecture related to the YOLO 2, they are looking for the pixels where they are present, how to find the locations. So the basics of all these started with the computer graphics. Okay, so those who have studied the computer graphics, those who know about the pixels, okay, they can understand how to trace the objects. So the concept relies on that. And right now we are dealing with the different deep learning algorithms, as also mentioned here, CNN, RCNN, and all such things, so that are very much helpful in performing the object detection, image localization, and object localization whatsoever. Okay, any doubt, please ask me. Is anyone having doubt? So let me share the another screen and explain you about the YOLO. Any doubt? Yeah, yeah. Whatever I explained, please. If you have any doubt, please let me know. What is image classification? What is object detection? Anyone? Doubt? Yes, yes, Shashikant. Yes, yes. Please ask. See, layers, Shashikant, I have deeply explained about each and everything in my past projects. Okay, each and every layer, those who are present, they know about these that I explained for my previous projects. Because the previous project which we did was related to image classification only, and the project title was auto parts classification. Okay, there we have used Inception V3 and VGG 19 algorithms or architectures for the classification. Okay, and I have explained CNN completely over it, so I will share the content of the recording with you, Shashikant. Okay, so if I get on explaining these things right now, so my project, the main thing is okay. Any other thing? Yeah, sure, sure, sure. You can ask the question. Anyone is all are free to ask the questions. I will give you the suggestion or the answers whatever required. Okay, so any other option available? See, right now, yes, there are other option available for the YOLO. For example, CV lib. This is also the library for available for the object detection. PyTorch, PyTorch and Torch Vision. These are the libraries which are performing these kind of image classification and object detection. So you are having multiple libraries to perform this kind of task. Only the point is we are much more concerned about the YOLO thing, because the efficiency, accuracy, and the speed which we are getting in this techniques are much more better than those. Okay, and the another point is, they are they can be used in, as I told, that in videos also, because in this session I will let you explain about the how to, in real time video detection also, we are going to perform the analysis. So in previous or the different libraries, I haven't seen that thing, how to get the object detection in a video portion also, but here in YOLO it has been possible. Okay, so that is why this library has been a major concern. Okay, is that okay? Fine. So let me change another screen. So here let me explain you about the YOLO 7, what exactly YOLO 7 is my screen visible? Okay. So what does this YOLO 7 means? It's an object detection. There is obviously, I just told you that there are research publications on the basis of that, and they have done modifications in the architecture. So YOLO 7 is a new state of art from the YOLO family, and according to the research paper, it is the fastest and the more accurate real-time object detector. So the question which you asked to me, sir, why we are using it, are there any other options? Yes, there are other options also, but the point is we are looking for the fastest and the most accurate real-time object detections. Okay, so here, according to the YOLO 7, the best model score 56.8% average precision. Okay, average precision for the object detection, that is, which is the highest among all the object detectors. Okay, and it takes about 5 to 160 frames per second for the analysis. Okay, for the analysis, that means in YOLO 7 also we are having intermediate models. Okay, in YOLO 7, this is the family actually, YOLO 7. In this we are also having multiple other models also, which can be used separately to perform the detection, that I will let you explain when I will just get started. Okay, so YOLO 7 has reduced the number of parameters from 40% and the computation to 50%. This is the main thing which we have achieved in this YOLO 7. Okay, so now the next thing is, let us talk about the architecture. See, YOLO works upon fully connected neural network. Fully connected neural network. Okay, it has been recently added to YOLO family, and the framework consists of backbone, head, and neck. Three main components are present here in the YOLO architecture. Okay, so backbone is basically which extract an essential features from the images. Okay, head is something and feeds them to head to neck. Okay, just extract the features and feed and perform the feeding. The neck collects the feature maps extracted by the backbone and creates a feature pyramid. Okay, then it performs the pyramid of the features. Okay, these are the features, these are essential features which are present. Let's make an pyramid of it. Okay, and then finally the head consists of the output layers and have the final detections. Okay, so three portion: backbone, head, and neck. Backbone extract the features, give it to the head and neck, and they perform the analysis, and finally your head consists of the output layers which give the final detections. Okay, so following is the table related to the architecture. There has been question asked to me, sir, what is the difference between the YOLO version 3, 4, and 5, and also things? Okay, so YOLO 3 also uses FCNN, fully connected. 4 also and 5 also, they all are using the same technique, fully connected convolution neural network. Okay, the backbone, that is the darknet. Okay, and darknet, this is CSP darknet 53, this is CSP darknet 53 also. You know what is this darknet, imagenet? We have used in most of the deep learning algorithm these things. So the point is, these consist of dark net and image net, they consist of features. Actually, they consist of many images. Millions of images are present in these kind of techniques: darknet, imagenet, and this is CSP darknet 53 and all those things. So what happens is they consist of features actually. And by use of the features already available in them, we submit our image for the training purposes. And what happens is the training is been done by referring to the features which are available in them. Okay, and then your model get understand, okay, this we have known, okay, so this could be the feature. So they keep on feeding, we keep on feeding by this backbone, okay, referring to these. And then we are making our head and neck to get trained. And accordingly, after understanding all these features, the bounding boxes has been created. Okay, and the last one is the loss function. That means what is the energy losses during the training, and because it happens during the deep learning, we have seen that there is a loss, there is a validation loss, there is an accuracy, there is a well accuracy and all those things when we train our deep learning models. So this is all been happening in these versions of YOLO 3, 4 and 5. Okay, so what happens in YOLO 7? Why it has been new? What's been present in YOLO 7? YOLO 7 improves the accuracy and the speed. That was I was telling you previously also, because of several architectural reforms. So the only thing happens when we get a new model, that is there is a change in the architecture. Okay, architectural changes. Similar to scaling YOLO 4, YOLO 7 backbones do not use ImageNet pre-trained backbones. Let me again pinpoint to you. I took this name, ImageNet, DarkNet. They are already consisting of millions of images. Okay, millions of images. And here YOLO 7 backbones do not use image, or they don't use pre-trained backbones. No pre-trained. Rather than the model are trained using COCO dataset. COCO dataset. Now, what is this COCO dataset? Again, if I talk about this COCO dataset, this dataset also consists of millions of images. Okay, COCO means uh, this is your object detection only. Okay, and we different kinds of objects are being present. That means common object in context. COCO stands for common object in context. Okay, this is the full form of COCO. And let me explain, or let me share another screen with you if it is required. No, it's okay. So COCO, that is, as I told, that common objects in context. And it plays very important role in computer vision and its applications in object detection, face detection, pose estimation, because right now the people are also doing work upon the pose estimation also. For example, if you are working on the gym. Okay, so how many push-ups are you are doing? So there is a complete posture detection. It will connect your activity of your body with like bone like structures. Okay, so right now the people are also doing the process related to it. So this data set, this is also huge data set. What is the name? Common objects in context. Okay, so YOLO 7 takes the concept of COCO object detection. COCO object detection. Okay, then what happens is the similarity can be expected because YOLO 7 is written by some authors, which is been scaling YOLO 4. Okay, what are the architectural reforms here? We have used extended efficient layer aggregation network here, and model scaling has been performed here. Okay, there is one more thing, that is trainable bag of freebies present here. That is planned reparameterized convolution and course of auxiliary and fine for lead loss. Okay, let me show you what is this efficient extended layer aggregation. This EELAN, it has been inspired from the previous research papers which have already worked upon the YOLO. Okay, and the most impact they gave on the memory access. Okay, how the layers has been connected, how to access the memory fast, what is the input output channel ratio, how activation functions has been used, and what is the gradient path. Okay, so this is certainly an architecture which you are going to see in EELAN. Okay, and the previous work which has been performed, this is the architecture. Okay, that means 3 cross 3 CC, 3 cross 3 CC, and 1 cross 1 4 CC. These are the convolution layers which are being present, okay, in this architecture. So these are certainly the change has been done in the architectures. See, you did not have to go through that what exactly been, but a basic knowledge has been required for the understanding. Because why we are doing, I can also get started with the project directly, but there are some people who don't know about the basics. Those who know about the things also, they are not been too much having a knowledge. So that is why I first going to make you understand what the concept says. Then we have performed the compound model scaling here in YOLO 7. Okay, that means, yeah, yeah, EELAN. Yeah, COCO dataset. Yeah, 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 already dataset available, yes. Yeah, 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 yes, yeah. See what happens. Input is given by you actually. Okay, input image, input video you give from your side, and the COCO dataset is already. I can say it's like pre-trained. Previously, the dataset which I did name, that is ImageNet and DarkNet. They are also the pre-trained models, pre-trained dataset of the images, which consists of the features of different objects. Okay, here also COCO also comprises of millions of images present in it. That means related to the house, car, people, train, truck, whatsoever, bicycle, whatsoever. They already consist of people. Okay, it consists of all kind of information in this particular data set. Okay, and what happens here in the COCO, what are the features? If I just basically say, it performs object segmentation, recognition, and it classify the objects into various categories. So there are various options available in COCO dataset. And here you understand by the word, what is the word we have taken? Context. Okay, common objects in context. Context is something, context is an information basically. Okay, and for example, let me tell you a very basic example. If I'm sitting here and I'm searching for a restaurant, okay, so the context is something, a location. Context is a location. My mobile or my whatever the device which I've been using, it has been using location as in context. And whatever be nearby the restaurant, for example, if I am searching for the restaurant, it will not show me the restaurant which are present in Bangalore. No, it will only show the restaurants which are present where, near my locality. Okay, so context, here we are working with the context, common objects in context. Okay, so the objects which are looking similar with each other, okay, which are having common context, which is having some common information, okay, which are having some common features, this data set is prepared on the basis of it. Now you got my point. It's not like simple collection of images, no. Previously darknet, imagenet, these are the collection of images where we are, but here we are extracting the features. On the basis of features, this data set has been prepared, and it's again comprises of 200 000 more than images. Am I you got the point? Elan, again, it's an architecture. This is an architecture. Here also it has been shown as an architecture. See again how the convolution layers has been connected. What the layers are being internally. Okay, how the computation has been performed by it when you give an image, how it converts, how it extract the features, how we perform some other tasks. So this is what been present in these layers. So if you want to go some more understandings related to it, it's better to go through the research paper which is based upon EELN. Okay, so yeah, we need to go through the research papers. Okay, so I'm just going to explain you here that what exactly been happening in this particular YOLO 7 model. What is the architecture of YOLO 7 model? What are the components which are present in the YOLO 7 model? And giving you just a brief explanation of about the architectures. Okay, so we need to go. Then there will be this session will be something. It will take some more time if we just go through the papers and explain you each and everything. But this is the architecture which has been available on this respective website. Okay, so you need to go through for deeper learning. Okay, is that okay? Fine. So if we talk about the compound scaling, that means we are looking forward for enhancing the resolution, width, depth, and stages. That is the number of pyramids which has been going to perform. Because we have already divided this into three components. Okay, and these components, backbone, head, and neck, are performing the task. Backbone is going to collect the features and giving to head and neck, and they are creating the pyramids of the features. Okay, so this has been done here in case of scaling. Okay, so this is the compound scaling. Okay, that means we are collecting the features, and then after collecting the features, we are just organizing them into what is the depth, what is the width, what is the height, and whatsoever. Okay, this is the arrangement, computational blocks related to it. The next thing is the trainable bag of freebies which are present in YOLO 7. Okay, that is reparameterization. I've already told you that it has reduced 40% of the parameters and 50% of your computational task, YOLO 7. So 40% of the parameters has been already reduced. That means reparameterization has been done. So the parameters which we have already assigned in our layers, they can be further reutilized for our computation purposes. Again, we can use those parameters. In previous my lecture also, we have seen VGG 19 and Inception V3 architectures. There also it happened. For example, if we are having 5 cross 3 5 cross 5 layer, then we are fabricating them into 3 cross 3 and 3 cross 3 and something like that. We did the same task somehow. What so here also we are going to use the same parameters again for the computational purposes. So here also some diagram has been there, that is 3 cross 3 convolution plane net, then REP plane net, ResNet, REP ResNet. Okay, so these are certainly the architectures available. How the reparameterization has been performed. So basically, if you talk about the reparameterization, you are going to reutilize your parameters which are available on the certain layers. Okay, this can be achieved how the connection has been done between the layers. Okay, so there could be some cyclic connection in intermediate connections between the layers. The basic understanding will be much more being explained by the people who have done the changes in the architecture, those who wrote the research paper on this. So they will be much more better person to let us explain what why they did change in this kind of architectures. Okay, fine. These are certainly the experimental results which we achieved from YOLO 7 using COCO object detection. Okay, and YOLO, it's a family. Internally it consists of different weights also. Okay, that I will let you explain when I just get to the coding. I'm just getting over the coding here. Okay, so this is your results which we obtained from different YOLOs, that is YOLO 4, YOLO V7, Tiny, E6, D6, E6E. These are certainly the internal models of the YOLO family. Internal models. Okay, that means you can say just kind of internal versions of YOLO 7 or YOLO 4, whatsoever. All right, and here are, you can, on any website you can check the comparisons, how many frames per second has been used, how many parameters has been utilized. Okay, and what is the your AP, that is the precision, average precision achieved in these algorithms. Okay, or in these techniques. Fine. So I hope you got a better, or I just say some kind of understanding related to the YOLO. Okay, and now I'm going over to my coding section. I'm starting my, yeah. Yeah, as of now. Yeah, as of now. Yes. V8, obviously. Yes. No, actually, we look forward for the accuracy, basically speed and accuracy. Two are the factors. Whatever the algorithms, the algorithm, to be very basic, if we talk about the computer science or computational thing, in algorithms we check two things: what is the time complexity and what is the space complexity. Okay, time complexity, that means how much time an algorithm takes in the RAM to get executed and produce you the results. Okay, so basically the choice of the algorithm which you take to perform any task should relate with the algorithm time complexity. So here, as it has been told that YOLO has been reducing the parameters by 40% and computation by 50%, that means it is obviously the faster, and it is also showing that average precision is 58%. That means it is much more having higher efficiency than other any other object detection model. So this makes a sense. That is why we are performing this YOLO 7 implementation here. Okay, fine. um, Now I'm sharing you the Google Colab. Okay, so let me share you the Google Colab now. From here, I request you all, please be attentive. I will be explaining each and every step. I have already executed the code. However, I will execute some instances in front of you all, and I will explain you each and everything here. Okay. So, in the starting, also, I told that you need to code over Google Colab. The reason is this is a deep learning algorithm, and since it requires some computational efforts, so it's better to use the computational capabilities from outside rather than on your system. Because what happens is, when I also execute these kind of things, in fact, if I run some other deep learning models on my system, it gets heated up. My computation, it gets heated up, okay, quickly. So, let's get started. Also, you will get better opportunity here. Instead of installing the requirements or different other libraries, it's better, you will get all the things available on Google Colab. So you can, Google Colab runs online. Okay, you need to connect with the internet, and then only you can run the Google Colab. So those people who haven't done coding over the Google Colab, no worries at all. Just on Google, search Google Colab, open it. Okay, and then you will get this kind of um, visualization over it. So, let me increase the resolution also. Now it is much more clear visible. Is it now much more clear visible to all? Okay, fine. Once you get started with the Google Colab, what you have to do, the first step, step number one, if you are writing something, please do write or note. That will be much more better. The first step is, you need to go here with the runtime. Okay, go with the runtime. Okay, and in runtime, you need to go here with the change runtime, and then you need to select GPU, that is Google Processing Unit. Just use GPU. What kind of hardware you are going to use, you have to use here GPU. Okay, and then after selecting GPU, save it. Save the GPU. Okay, because I'm not using my local processor or something like that. I require some additional processing elements. So you just go to the runtime. Okay, change runtime type and select the GPU. Okay, and save it. After performing the save, you connect. Here it is the connect button. Is connect button visible to you all? Is it visible? Here is the connect. Okay, so after selecting the processor, click on connect. Okay, so it's going to connect right now. It's connecting. Now, after connecting, after initialization, it will provide you something. Okay, It is connected. So here you got RAM and a disk. Google has been providing you the RAM and a disk from his side. Okay, now you're not going to utilize your resources. Now we are hiring the resources from the Google. RAM available, disk is also available from the Google side. Okay, I guess till here everything is fine. Now the next part is, you need to mount your drive. You need to mount your drive on the Google Colab. Mount your drive means you need to on drive, what actually is being present on the drive. On drive we are available with your data. Okay, with the data is available, so we need to mount. That means we need to give a path of our drive to the Google for it to access our data. Okay, so how to mount? Because this is something which has been very much important to understand. The first step, you need to mount. So from google.collab, import drive. Okay, drive.mount content slash g drive. Content slash g drive. Okay, this is what you need to perform. This is step. It will mount your drive on Google. Okay, so let me run this code. What happens is, it will ask for the permission. Okay, it will ask for your permission whether to mount your drive or not. So you just click on connect to Google Drive. Okay, you have to write here connect to the Google Drive. So it will give you the authorization for the connection over the Google Drive. Connect to the Google Drive. Okay, and then one pop-up window will open. This has not been visible to you. There is a pop-up window has been opened in front of me. Okay, so I am clicking on my email address from which I am working on this. That is, the email address is the email from where you all received this invitation of connecting. Okay, so I'm clicking on it, and then I am giving it allow access. Okay, after I gave allow access to this, okay, the same kind of question will be asked to you. Now my code is executed fine. You can see the green color tick mark. Is it visible to all? Here you need to be very much attentive and interactive with me. Please be interactive. Just keep. Okay, yeah, yeah. Yeah. CD and all these things, these are basically, for example, CD is the change directory. Okay, PWD, here we are going to check in which directory we are currently working. Okay, so this is something which we work on command prompt. And so okay, so yeah, these kind of commands we also see on the Linux shell also. You're right, you're absolutely right. We used to see all these commands on Linux also. Okay. Okay, for the data set, okay, you can do one thing. You can download an image from your side. Okay, if you want to perform the task, you can do one thing. You can download an image from your side of a person in a bicycle. Okay, just search on Google quickly and download an image with a person and a bicycle. Both are present in that particular image. Or rather, you can download an image with the people who are traveling on the streets or something like that, with the buses and cars are present. You can download it from your side. Both you can download the both, video also, image also, no worries. And I will let you know how to download the video also in a simple way. Let me proceed now. After mounting the your directory, your drive. Yes, any other doubt? Anyone want to? Yes, Chetan. This is the path. Yeah, path. No, and this is your G drive, your Google drive. Yeah, we uploaded. Once you open your Gmail account, na, there is a drive present there. Okay, so that drive has been uploaded here. Now the next thing is no, yeah, yeah, now the next thing is, let me change the directory from G drive to my drive. Okay, whatever the things which are present in my drive, I did change the path here. Now I'm working on my in my, I have came into my drive. Okay, after okay, if you want to confirm, if you want to assure that are you working on your drive only, so exclamation pwd. Exclamation pwd tells you that where actually you are present at means at now where you are. Okay, so you are now present in my drive. Okay, you are present in my drive right now. Now in my drive, okay, till now you have mounted your drive, you have changed the path and everything you have done. Now what you have to do is, I need to create a folder in my drive. Okay, till now I guess everything is okay to all. Any doubt till now? Everything is okay? Everything is okay? Okay, now the next proceeding is, I need to create a folder in my drive. So if you guys are working, if you guys are working right now side by side with me, so you need to create a folder. How to create a folder? I need to import OS, operating system. Okay, let me just write import OS. Okay, and then yeah, yeah. Okay, okay, scroll up. Okay, okay. Um, okay, just no, 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 not that much. Okay, just a second. Continue, no? Okay, just okay, okay, just hold. Yeah, yeah, sure, sure. You can use it. No worries. You can use it. No worries. It will detect it as a person and a bike. But okay. I am mailing you all the code. Okay, just hold on a second. I'm mailing you all the code. So it will be easier for you to download and then work upon it. Okay, I'm mailing you all the codes. Okay, just a second. So this will be an hands-on training for you all. Okay. Actually, I will be mailing the two codes to you all. Okay, one code is right now which we are performing, that is YOLO 7 code.ip ipynb file. Another will be one more file I'm sending you. That means I'm sending you two files. One file is YOLO 7.ipynb. So right now we are working on YOLO 7 code.ipynb file. Okay, sent from my side. I have sent to you all. You will receive on your mail. Okay, so let's proceed ahead. Now the next thing, once we have imported the OS, I am going to create a directory. I am going to create a directory in my D drive. So directory name can be anything. You can use any name here in the directory. Okay, either you can use your name or any other name. Okay, just any name you can use. Okay, so import OS. If not present in the OS, if not present in the operating system, this directory, so create a directory with his name. So you can create directory by your name or whatsoever. Okay, so let me execute this code also. It has created the directory. Okay, After creating the directory, what we are going to do is we need to go inside this directory. So again, I'm going to change percentage cd. That means change from this to another directory. Okay, that means your current directory, this directory, the name coding, the coding bug, I'm going inside this directory which I have created recently. Okay, so let me execute this code also. Done. Here is the path from content g drive my drive to the coding bug. Okay, so you can name any directory here. Okay, and you can switch to this directory by these commands. Now what happens is I need to clone YOLO 7 into this directory. Now we need to perform the cloning. It doesn't mean that we need to pipe install YOLO 7. I already told you previously, we are not going to do this kind of task. Here we need to perform the cloning of the original. So for cloning, you can do one thing. You on Google search you can type YOLO 7. YOLO 7 you can type on the Google search, and the first option which you will be getting is the GitHub Wong Kin YIU YOLO 7. Okay, that is, he is the person, he is who has created this setup for the YOLO 7. This GitHub profile. Okay, so you will get this link. Okay, let me copy and put it on the comment section. Okay, let me put it on the comment section. Here it is. Here it is. GitHub, github.com Wong Kin YIU slash YOLO 7. Okay, the first option itself. Okay, so what next to do? We need to clone. We need to prepare a clone of this library. So for creating a clone of this library, we need to write like this. You have to use a git command. Okay, git command. So exclamation git, write clone with a space, write clone, and copy the complete URL which I have shared with you on the comment section. HTTPS github.com wonkin yiu slash YOLO. Okay, just copy this complete URL dot git, complete URL dot git. Okay, just clone this thing and run this. Here it is giving me fatal. Actually, I have already YOLO 7 present in my directory, so I don't require to clone. But however, if you are doing it for the first time, it will quickly clone the complete YOLO 7 in your drive. It will not take much time for the cloning. Just in a fraction of seconds, it will clone everything. Okay. Now the next part is, after cloning, let me go to this drive. Okay, let me go to this drive. I am here in this drive. I'm present in my drive. Okay, after presenting, after being present in my directory of YOLO 7, what I need to do, see here, I guess let me check the folders. Here it is. This is my G drive. This is my drive. In this my drive, I am having this folder, coding bug. Here I am having YOLO 7. Okay, and in YOLO 7, you can see all these are now, all these files are present. All these files, along with some folders, are already present in my YOLO 7 folder. I hope you all got it till here. You got everyone till here? Is it clear? Okay, so here are certainly the all files and the folders related to YOLO 7 has been cloned. Now, now what you can do, as I told you previously, let me get back again here on YOLO 7. In YOLO 7, you can see Okay, let me go to the models. Okay, then let me check. We are going to utilize any of the models which are being present in the YOLO 7. Okay, so here what we need to do next is, I hope you all have opened YOLO 7 official website of GitHub. From there only you have copied this. Okay, from where you have copied this? Everyone has opened this GitHub. Everyone has an opened that GitHub this HTTP. Please do it. Please do it. Please do it. Open that. Just type YOLO 7 on the Google search for the and first option will be that GitHub link only. Okay, and let me reshare my screen to that. Later I will come on Google Colab. Tab. Okay, here it is. This is the website from which I will be taking everything. Okay, here is the website. Wonkin. Now, now what we have to do? We have created the clone of YOLO 7, official YOLO 7. We have created the clone. Now here, these are the performance models of YOLO 7. I have already told you that YOLO 7 is a complete package. It internally comprises of YOLO V7 our model. It comprises of YOLO V7-X model, YOLO V7 W6 model, E6 model, D6 model, E6E model. Internally, it comprises of all these models. Okay, so we can pick any of the model from here and perform our analysis. We can pick any of the model here and then we can perform the analysis. So what you have to do, any model you can pick it from here. So let me take the first YOLO version 7. So you just do right click here, do right click on YOLO V7, copy link address. Okay, perform copy link address. Okay, copy link address. Okay, you can take any of the model. It's not mandatory that I am taking YOLO V7. You can take YOLO V7 V7-X also. Okay, you can take this model also, but I am taking YOLO V7. Okay, copy link address. Click on it, right click on it, and take copy the link address. Then I'm going back to my Google Colab. Let me go back to my Google Colab. Okay, I'm going back to my Google Colab. I hope my screen is visible again for the Google Colab. Now, what you need to write? You need to write. Is my screen visible? Okay. Now, what you need to do? Now, what you need to do? Exclamation W get. That means we get. Exclamation W get. You need to paste what you have copied from there. Just paste it here. Paste it here. Whatever you have copied, just paste it here. Just paste it here. Exclamation W get. Just paste it here, and run this particular file. Okay. Just run it. Paste and run. Execute this code. Please let me know if you have done, because before starting I haven't decided that I will be doing the live demonstration here. Okay, I will be doing live demonstration for you all, but you guys will also be doing the same with me. Okay, uh, but let's see, it makes an interest because you also want to see the images and the videos how the detection has been performed, so it's a good idea. So done. Okay, fine, I guess got the reply that it has been done. Okay, and this is the processing being performed. So I'm just these are the internal models which are present in YOLO 7, and they comprise of certain weights assigned with them related to the features of the images. So what is this YOLO V7X or WD6 and E6 and also things? They are having different weights associated with them related to the images. Yes, Chetan. See, you can scroll it down. Okay, you will be able to see. You're not able to see this link. That's what you're talking about. See, I have mailed you, no? I have mailed you the code. I have mailed you all the code that is present in that particular code. Download the code. It's been present. This link is present there in the code. That is why I priorly mailed code. Now, what happens is after executing this code, we need to perform certain modifications. We need to perform certain modifications. Now, listen very, very properly. Okay, I need to perform certain modifications, and let me share my complete desktop. Okay, stop presenting. Let me share my complete desktop. Your entire screen I'm going to present. Okay, share. Now I'm sharing everything. We need to perform certain modifications. Okay, for performing those modifications, what I need to do, I need to go inside my YOLO 7. Okay, so you know what I opened here is I opened my drive. In my drive, there is a folder coding bug. In coding bug, I have already created one folder YOLO 7, and YOLO 7. All the files has been stored here. Okay, everything has been stored here. So you need to go inside YOLO 7, and then you need to perform certain changes into certain folders. The first change you need to do with this folder utils. Okay, I'm still hanging on with you guys. You do one thing, go to your YOLO 7 directory. Okay, go to your YOLO 7 directory from your drive. Okay, and then open this folder utils. Open this folder utils. You can see various other files also here, various different other files also present. Okay, then you need to open this file datasets.py. I hope it has been visible to you all. Okay, datasets.py. This is the file datasets.py. Are you guys working on it? Okay, one more thing. Because I have saved every part of the work in form of images too, so it will be helpful for you to understand by that. Okay, now data set file has been I guess it has been okay. No modifications required. There is one more file that is called as detect.py. If it has been here, let's check out detect.py. Is there any file detect.py? Yeah. Okay, yes, in YOLO 7 folder. Yes. Data.py is present. Where in YOLO 7 it has been present? In YOLO 7 there is data.py. So it's better you just here it is. In YOLO 7 data.py is present. Just open this data.py. Okay, and there is one option open with text editor. You can check it out above. Open with text editor. So just click on text editor. Open with text editor. In YOLO 7 folder, you have been available with detect.py file. Okay, this file has been present in YOLO 7. Okay, and open this file with the help of a text editor. Open this file with the help of a text editor, detect.py. Are you getting this point or not? Are you getting this? No, don't go with utils right now. I will let you explain what will we have to do in the utils. Just you do this task first. Yeah, detect.py na present. In detect.py, come to line number 17. Come to line number 17 and write random.seed1, because I need to stop generating random colors during my execution. I need to stop for generating the random colors during my execution, because if we run the object detection every time runtime, it will give you the same colors. Okay, for that purpose I need to just perform this task. Okay, I need to perform this task. Just I will write random dot seed one. This I will be doing. Okay, this I will be performing. Line number 17. You have done this thing? Random seed one. I have also commented. Is you can't is my screen visible? Is my screen visible or not? See, data.py file is in YOLO 7. No, no, not in util. Come out of util. In YOLO 7 it has been present. Your main folder it is present, detect.py. And yeah, yeah, yeah. No, see, right now we need to do some more modifications. Okay, so just hang on this with this file only. See, random date seed, because every time we are performing the execution, okay, so it will generate the random colors during the execution. Okay, and if we run our object detection on a machine every time, it will give you the same color. Okay, so we don't want the same colors for multiple executions when we are running it again and again. Same colors we don't need. We need different colors every time. So that is why I just made random dot seed one. Huh. Huh. See, yeah, it's a random number actually one. He the seed number is one. That during runtime, because we need. See, because see, yes, I can connect with that, because just check out the next methods or the which are being available. Definition detect the next methods. This is a big file, detect.py. This is a big file. Okay, it comprises of many things. Okay, and here the detection has been done related to the images, okay, or the frames which we do check out in the videos, because the videos also been converted into different frames, and every frame will going to perform the same application. So here random dot seed means the we are including it in this code. Every time when the detection is been going to occur, we are going to give different colors, not the same colors every time. Okay, so that is why. Yeah, 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 yeah. See, it is one. See, this is certainly a common specification which I believe will work, and it did work with this particular task. Okay, if you want, yeah, you can give any other seed value also, no worries. For one actually give this number, that means one time execution you got the color, that's it. Now for the another, every time, every execution, one basically means one execution, the colors which you got, okay, fine, that's it. Again if we execute this code, that will be again considered as a one. Okay, random one, that means that will be new execution. Are you getting my point, what I'm trying to say? One means only one execution, the colors which has been allotted, okay, you got this point. Second, again we are going to execute, okay, one time execution, you got this point. Is that okay? Are you able to understand what I'm trying to say? If you give 2 or 10 or something like that, random seed means, okay, that means 10 is certain level. After 10 executions you give some different colors, till 10 executions you are having the same color. Yes, 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 add this line. This, it's not been present in the code, you need to add this line. Okay, done. Adding done. Okay, all has done the adding, because whatever I did now, I create captured the screenshots of these also, because now the next portion might be certainly lengthy. Okay, add now. Next line number 70. Come to line number 70. I hope my screen is visible to all. I'm sharing some screenshots. Is it l- little bit small font? Okay, no worries. Come to line number 70. T0 equal to time dot time. 69th line is this. T0 equal to time dot time. In 69, it is T0 equal to time dot time. Is it visible? Okay, there, if I just scroll it down to this place, 70, you need to include this line, start time equal to 0. Start time, that means I need to capture the frames. I need to capture the frames, frame per second. I need to show frame per second in my videos also. Okay, so I need to capture the frames. So there is some timestamp I need to give here. Okay, so start time, time T capital. Added, all added. Let me increase the size. Start time equal to 0. Okay, now after performing this, you need to get towards the line one number 34. Stream results, line 134. Line number 70, that's what I'm sharing with you all. Start time equal to 0. Start time equal to 0. This is line number 70. This I have already highlighted this point. Yeah, two changes. Random seed, and you have, okay, yeah. Now this is you need to include a random line number 70, start time equal to 0. Okay, then next I told you to come on line number 134. Line number 134, here it is. Line number 134, you need to include all these. I am highlighting you the complete code. Stream results, if dataset.mode is not equal to image, current time equal to time dot time. Okay, let me copy this into the comments. Copy and put it here in the comment. Okay, I have copied this code and put it in put that thing into the comment section. And I'm also highlighting this where you need to write. Okay, done. Okay, okay, done. Just check the orientation. It should not get like indexing should have to be proper. And here what we are exactly doing is we are calculating the frames per second actually. Okay, we have a start time, we have an end time. Okay, and then we are calculating the fps, that is fps equal to 1 upon current time minus the start times. Okay, so whatever the frames per second we are going to calculate, that has been present here. Okay, and here start time, then we are assigning the start time to the current time, and then we are putting cv2 dot put text. We are putting the text on that particular frame. That means I am going to show fps on my image. Okay, that means the video. What happens, a video is also being created by the images only. Now images, when you run the images in a quick interval of time, it will be converted into video. So right now when I am uh, uh, performing the inference, that means I'm fabricating the images, I'm detecting object in every images, and then I'm running those images in a very quick time, into frame per frame per frame per second. It will be converted into video, and every time you will see the tag, the bounding box, and in the top of the bounding box you are going to see that, okay, this is your fps, frames per second. You are going to see everything. So here uh, cv2 dot put text, we are going to put text fps over it, frames per second over it. 2070, this is the bounding boxes. Okay, and this is your color 0 to 55 0, this is your color, this will be the green color. Okay, so there are some parameters which are available in cv2. This is cv2 is, this is open cv, computer vision library. Okay, so we are using computer vision library here, and we are just tagging, creating the bounding boxes over the frames, and we are writing that fps what are the values available for it. Okay, so this calculation, I guess, all has performed this task. Okay, now the next line number 167. Go to line number 167. Go to line number 167. Okay, 167. Actually, what you need to do is, here if we come over line number 150, line number 150, just copy this thing. Line number 150, just copy this. Printf the image with the result is saved in, just copy this. Perform a copy. In line number 150, there is a comment part. Printf the image with the result is saved in, say, path, and also just copy this thing. After copying this, put it here in line number 167. Just paste it. Just paste it and uncomment it. Paste and uncomment. Yes, comment. Yes, comment. Yes, yes, comment on it. Comment on it. If it is uncommented, comment on it. Comment on print this line. Because I need to save the things for images also and for the videos also. So that is why I'm just picking this line. And for image and a video, both I'm going to perform this task. So that is why I'm just copying this thing and putting this over line number here. One, here it is, 167. Line number 167. 167. Have you put all 167? Everyone did the same. Okay, so now after putting this here, now we can go to line number 129. 129, I guess. Yeah. Nah, the output, yeah. We need to change the text also. Previously, it was image. That is why I was telling the this thing. Previously, if you just check the line number 150, it consists of the image with the result. Now, instead of image, you do one thing. There is a put a change. Instead of image, write output. Delete image, write output. The output with the result. Because I need to work upon both image and the videos. Okay, so just change in image to output. Done? Everyone done? Okay, now the next thing is, go to line number 129. In 129, you are seeing plot one box, and also seeing, you're seeing line thickness. Change the line thickness to 1. Okay, because I don't want any thick bounding boxes. I want sharp bounding boxes, not thick bounding boxes. One is already there. Okay, if one is already there, then yeah, it's already there. Then nothing to change. If it is already there, no change. Okay, you've done all these changes. Fine. Save this file. That's it. Save this file. Save to drive. There's an option save to drive above. See, my file is already saved, so no, I will not be doing anything. You just do one thing. Save to drive. Done. All. So are you feeling excited with this task? Unless and until Abhi you're not, you're okay, you're copying. Okay, so this is the learning phase now. So what can be done once you learn this thing, then you can try this project with different images, different videos. Hmm. 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 I did explain about the fact that how we are giving the frame per seconds, because I need to show the previous changes which we did right now here also. Stream results, and I did this, that I explained each and every point that we need to. uh Yeah. Okay. Hmm. 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 Okay. Hmm. 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 Okay. 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 Since step by step I'm coming to all these things, okay, because there are other folders, and what are the uses of these folders, what we will get in these folders. Till now, whatever I did explain, that is as per the uses detect.py. This is the Python file which is used to perform the detection over the images. Okay, as the name suggests. Yeah, yeah, yeah. Yes, yes, yeah, yeah. Save to drive. Yeah. No, 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 not to download anything. Just save to drive only, because your all files are present in drive. Nothing to download. Okay, and this is your complete code for the detection of the images. And here they have used the libraries. Let me tell you, libraries, that is OpenCV and all such things, which are used to perform the detection. That is CV, Torch, and NumPy, and all these libraries. They have already this code has been already pre-created. Okay, and why we are doing these changes, the reason is because I require my type of expected output out of it. Okay, so the first thing, detect.py, this is to perform the detection over the images. Why we are doing the changes? The one change I started with the random seed, I told you, because I need different changes for every time detection has been executed. Every time I need different colors. That is why I put a random seed. Secondly, I need to show the FPS, frames per second. So that is for the reason, showing the FPS on the frames or the images or the objects which we are going to detect, I need to show the text over it. That is why I have put that particular text over it. Secondly, I need to show the output. Okay, where the output of this particular is this something I need to display. That is why instead of image, I copied that particular thing and pasted it some place. Okay, and I told, okay, the output is this which we need to display, whether we are working with the images, whether we are working with the videos. Next thing, the bounding boxes which will be created over the images. Here the thickness is, I need to mention it one, it depends upon you. You can mention it two, three, or whatsoever. That much the thick the bounding boxes will be. Okay, so if we are already working, if we know the concept of computer vision, CV libraries, if we have done some programs related to the CV, so you can have some idea about it. So you need to do the basic exercises related to the CV and all. However, whatever I am doing here, I will explain each and every part. Okay, and if we talk about other folders also, I'm coming to other folders also as per the use. There are, yes, there are other folders also available, what they comprises of, what we need to do, I'm coming over them also. Okay, let me uh, just as per the use, I'm going to show you everything. So detect random seed, that means one execution. What happens is random seed, every time we are going to execute, every time we are going to detect. So colors, here the path point is the colors. Okay, every time we need to have a different colors. Okay, not the same colors to get achieved. Okay, so that is why, because if you run object detection multiple times, it will give you the same color every time. So that is why I don't want this thing. That is why I put random seed 1. For every execution, let me get different colors every time. That is why I put this thing. Yes, 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 yes. Different type of colors, real time scenario. Keep it only one. Keep it only one, because as the question asked me previously, sir, why it has been one. I just put seed means it's an object value. It's a value one. One means okay, one time execution, one time detection has been performed. Okay, fine. Flourish it all. Now come with the next thing. Second time execution, it has been also considered as one. Finish it all, then second third time detection, fourth time detection, fifth time detection. Whenever you're running the detection, every time it has been considered as a new, it has been considered as a fresh. Yeah, 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 erased. That is why we are taking random seed one, and remaining all code is after random seed. So here is the method: detect def detect save image equal to, some code is there. Are you getting my point? Yeah, fine. So you have saved this file. Now, what I believe is there is no further changes required, so you can, after saving this file to the drive, you can delete this file. It has been, our task which we are going to perform has been performed. Now you can go to the utility. Okay, utility that we were going previously in YOLO 7. There is a folder called as utility, which we opened at first, and here that is datasets.py. Here is datasets.py. Open in text editor, again the same which you did with the detect.py. Open this with the text editor. Open this with the text editor. Okay, and get to the line number. Let me find it. What could be the line number? Okay, fine. Line number 181. Line number 181. Comment this line. Put a comment over it. Line number 181. Put a comment. In datasets.py, line number 181. Put a comment. Yeah, frame. Actually, here it is self account and self frame and, self captures and all these things. So we are not going to print all these. Okay, so that is why we are going to put a comment over it. Line number 181. I hope it has been also present on the same line in your in your file also. Yeah, you can see this code. Okay, that means here we are capturing certainly the video. Okay, and then images, and when we are counting the images and capture dot release, that means once your capturing has been done, then you're releasing, windows. If you are been aware of something related to the open cv files, you are going to get some idea about what's been happening here. Okay, but I'm not going to elaborate and explain each and every point here. But here, this is something we are capturing some video, we are converting into frames, we are counting these into frames, and we are performing the task. Okay, so right now we don't need this particular task to be done. We not want to print anything, how many frames and what are these to be there, so we are not putting it into the data set. Just put a comment here. Have you all done? Commented? Okay, so save this thing also. Save. My file is already saved. You can save this. No, nothing more to be done here. Saved. This all saved. Okay, so what are the changes which I require to done? I required to get done, I have performed. Okay, I have performed. Okay, I have performed all these. Now let me get back to your. Okay. Before getting back to the, I need to reconnect it, because when you are sitting idle for most of the time, this Google Colab get disconnected. Okay, so let me do one thing. You have downloaded some picture or video. Have you done? Okay, let me show you. Let me show you something. You can go on Google, and you can search for person with bicycle. Okay, some bicycle, CYCL bicycle. Okay, you can get some certain images, so you can download any of the image. Okay, after downloading this image, you need to put this image in your drive. In which drive? YOLO 7. Okay, for example, I pick this image, this girl image with the bicycle. Let me just save image as, it will be present now, it will be put present in the downloads. Then if once it has been present in the download, you do one thing. Acha, how you will put this image into drive, this I let me explain you this also. And there is one more thing, there is one more thing. YouTube, how to download the videos of the YouTube. Okay, how to download the videos, let me show you. For example, people walking on streets, this is the video. Just take some short video out of it, any of the short video. People walking on streets, short video. Okay, so for example, this is the video, 2:16, just 2 minutes video, 2 minutes 16 seconds. So you what you have to do for downloading the videos from the YouTube, you do not have to use any external software or application. Just do one thing, just click okay, come on the URL, and in front of Y, starting of the Y, YouTube na, just write SS. Just got my point, just write SS. Okay, and press enter. Okay, just write SS and press enter. You can download any video by using this technique. Yeah, okay, repeating. You know, any video, if you want to download from the YouTube, just do one thing. Go on the URL, on the top URL, na, www.youtube.com. Go on the URL. Okay, go on the URL, and in front of Y, just type SS. Just type SS. Okay, and press enter. You got my point or not? Everyone here. Okay, and now you can click on download. Okay, and then it downloads 750 MP4, 750 sorry 720 means 720 pixels. There are options available, 360, 720, or whatsoever. Okay, you can download it. It depends upon your internet speed, how fast it will take for the download. I have already downloaded this. Okay, so this is the simplest way to download the videos from the YouTube. No additional things are required. This you learned for the first time, or anyone knows new thing. Okay, okay, yeah, download folders. Yeah, this is download in download folders. Okay, now after that, after downloading, you do one thing. Again, go to your YOLO 7 folder. Go to your YOLO 7 in drive. Go to your YOLO 7 drive. Okay, all are in YOLO 7. Now do one thing. Here, there is new. In left hand side, there's in YOLO 7, there is new here. Okay, I hope you can see new. Click on new, and click on file upload. Okay, file upload. So from file upload, you where in from go to your downloads, upload your image first. Okay, upload your image first. Yeah, you can drag and upload it. Depends upon. I just teaching the simple stuff, what is possible. Okay, so you can drag and upload whatsoever. So you can upload your image here, and you can upload your video here also. Now it depends upon you how you can perform the downloading, uploading. Yeah, open. Yeah, you can where in downloads your image was there, na, bicycle, and person with a bicycle and person with a video, whatsoever. So you can download. You can upload in this particular folder. You download any of the image with a person bicycle and upload it here on YOLO 7, because here we need to work in this directory YOLO 7. Okay, in YOLO 7 you upload the video also. Okay, in here there is one image present with me, I guess. Here it is, bicycle.jpg. Bicycle.jpg. Here is the image I am available with. Okay, And here is one video that is okay, cars with mp4. Okay, and I'm not going to use this people.mp4. This video I have downloaded from the YouTube, and I've uploaded it on my drive. Okay, I have uploaded it on my drive. So you need to do the same on my drive, where in YOLO 7 folder. Done? All done? Done. Okay, fine. Yeah, directly in YOLO 7 folder. Yeah, both uploaded. Okay, done. Now let me get back to my collab. Okay, so stop presenting. I'm going back to my collab. No issue. Execute all the statements again. No worries. If it has been asking for the reconnected, just execute everything again. Yeah, from starting. No worries. Yeah. Yes, Umesh. Yeah. What? Okay, no worries, Sumesh. You understand the steps here. We need to upload in YOLO 7 folder. YOLO 7 folder. Yeah. Yeah. In folder itself. Yes. Okay. So here is my. I am available with my Google Colab code. Now we need to perform the detection. Detection. I am copying this code and putting it on the comment. Copy selection. I'm putting on the comment. You all just do the same. Just copy the same thing. Just do one thing. Only one change. Source, whatever the file name which you have given for your image, just do that. Bicycle.jpg. Okay, just do that. My file was bicycle.jpg, which I uploaded on the YOLO 7 folder. You could be have any names. You could be having any name with which you have uploaded. So just use that name. So here it is python detect.py. So the file which we did change, detect.py, we are using that. We are performing detection. Weights. Okay, weights. YOLO 7.pt. YOLO 7.pt means we are using YOLO 7 from YOLO 7 class. And weights, that means obviously weight means that is the features, okay, which has been assigned from in this model YOLO 7. That will be the weights. Then we are having confidence level. Confidence, that is the bounding boxes. Okay, bounding boxes. We need to bound the boxes. We need to create the bounding boxes. That is object detection. Then the next one is size 640. 640 is the size which is already present in YOLO 7. If you check the website, that website of GitHub, there 640 already pre-mentioned size of the images should be there. So I'm using the standard size only which is available on the website. I'm not using anything from my side. 640 is the image already available. And the source where the image is present. The image is present at source is, any name from your with which you have saved that particular thing on your drive, YOLO 7 folder. Getting error for which error? Okay, indentation. That's why I already told previously that indentation should have to be correct. Yeah, indentation. Yes. Here. That is why please, once you did copied this complete thing now, but indentation should have to be correct. So you need to go back to your dataset, your detect.py again. Okay, and then you need to recorrect the indentation and then save it again. What about others? What about others? Oh, it has given you, it has given you output. Have you executed detect.py? So are you getting like this? Are you getting like this? Okay, like this. Output with the result is like this. Let's check the last line. Output with the result. Check the last line. Yeah. Okay, okay. I'll let you know. I will let you know what happened. What about others? It has executed fine or not? You are also getting the same result. Only one person got the error, no? Because she did some coding problem, some coding error. Indentation was not correct. What about others? See, you will be getting this kind. See. You will extension should be JPG. No, no, no. Don't take WEP. No, no, no. That is a web format. No, take the image in JPG format. Again upload. Yeah. Again upload in JPG and pick any picture in JPG. So you will get like this. If it has been executed fine, you'll get like this. Okay. What about others? Please quickly let me know. What about others? Yes, Jayanti. Okay, sir. I got images saved. Yes, Jayanti. Have you checked your detect.py file? The line number. Okay. Please do indentation. Only indentation. That means where to place if and all. This is the only issue remaining. There is nothing an issue. I'm coming getting back to you, Jayanti. Just hold on. Okay. After the its execution. After its execution, those who have executed. I guess you have already executed and got some results. Yeah. Okay. So no, wait one thing. Wait. You those who executed this thing, it has been showing you that your result has been present in runs folder, in detect folder, in exp2. This image has been saved. Now I'm resharing my complete screen again. Let me reshare my complete screen. Let me reshare my complete screen. Entire screen I'm presenting. I'm letting you know where the results are saved. Okay, so in my complete screen, it told me that my result, you can check, my result is present in runs in detect exp. So the question asked to me, sir, what about the other folders? Kindly explain us other folders also. So here is another folder, runs. In runs, in detect, in exp2, here is a bicycle. After the after the see, here it is. You can check. This is the result. Is it visible to you all? It has performed the detection. Bicycle 95%, that is, accuracy. Person 94%. Cell phone 0.52. And though the confidence is 0.52, still it it got correct. Who got this thing? Who got this thing? Who got this result? Who got this perfect result? Anyone? Anyone who got this result? Shashikant, you got. Yeah, but the thing is, no worries. No worries. No worries, Shashikant. You got the result now. Okay, then unrecognized arguments. Okay, unrecognized arguments. What arguments you are giving? classes and argument update. Oh, this is something, weights are not correct or something like that. Have you took the image and everything? Okay. There might be issue related to the code which you did, because here it has been giving you unrecognized arguments in image 2. Unrecognized arguments. Mm, that means once your detection has been performed, it is not able to recognize your what kind of class, and not able to size, and you have used this code detect. Use this code detect. Same code you have copied. Just copied this thing, and you have saved your image in YOLO 7 and all those things. Everything you did correct. Huh. Indentation. Okay, okay. I will re-share the detect file with you. Pooja, have you got the result? Okay. So if you are working with the correct indentation, everything what I told you, definitely will get the result. So this is a result which is in present in your this file detect, in runs detect, and exp. Every time you execute your code, it will create new exp folder. If you take another image and run it again, it will create exp3, exp4, exp5, exp6, and so on. Now we did work with our image. The point is nothing. Just copy this code again. Just copy this code again. Copy this thing. Copy selection and go down and paste it here. No change you need to do. Just at the last, instead of image you have taken now, just replace it with the video. That's it. The video. I have saved it with the people.mp4 video. You just do with the video. That's it. In the last, just do it with the video. Previously it was bicycle.jpg. In the video, just write people.mp4 video. That's it, and execute the code again. Yes, yes, just change the file name, nothing else. Just change the file name. Just change the file name. Okay, I'm getting back to the code again. Let me re-share my screen of the Google Colab. Here it is. This is your file name. Just change the file name people.mp4. Just do it people.m, whatever the video which you got. Just do it like this. And Jayanti, no worries. I will share the screenshots of the changes which has been done to you all. Okay, okay. Let me share it right away. Let me share the screenshots right away. So it will be helpful for you. It will be helpful for you to understand what changes we did where. Yes, any doubt? Please let me know. Yes. Image. Somesh, image was done or not? Image one. We are getting error. Okay. Can you copy paste the error here on comment? Okay. I'm sharing, Janti. I'm just sharing the screenshots to all. If you guys made any mistake anywhere by typing or something like that, so you can please rectify that, because the only thing you're not getting the output might be some kind of problem or some mistake or something related to Euro 7 changes. in files, screenshot, screenshots. So I'm sharing the screenshots with you all. With you are getting the result video, Pooja, na? Uh, you are getting results with the video. Okay, well, it has been detecting. I hope you are okay. Square, na bounding boxes are there, and it has been going. It is also showing the percentage, and you know. So does it makes happy that you guys are now able to detect the objects in the videos also and images also? Yes, yes. Any video, just download the video and just execute this code. Yeah, yeah. With YOLO 7, yes. Okay, let me share the images also. The changes which we did because other people may not face the problem. So let me share the images because whatever changes we did, it should be available with you all in form of the screenshots. Okay, so let me. Okay, yeah, yeah, it may happen. Yeah, no. Okay, okay, no worries. Just for you guys help only. I share the code also. Now you are already available with this code. Okay, Somesh, um, can you verify the image file that is inside in YOLO 7 folder? Okay, YOLO 7 folder. I have already shown that the image which I am taking. I have already uploaded bicycle.jpg and this people.mp4 in my YOLO 7 folder. And those who have done the proper changes, saved the files, uploaded these images and the videos in this, definitely they got the results. Two people told me, sir, we got the results. Okay, okay, very, very fine. Yeah, you can download these videos, no? Without downloading. Yeah, we need to download that. Okay, you need to download that. Okay, then you can. It's been available. Now we can detect multiple images at a time, like uploading the folder. We can upload the folder, and then there are certain more commands related to zip and all these things. Then it will. Yeah, it can be performed. It can be performed. Though I haven't checked this particular task that we are uploading a folder which consists of 30-40 images and detection has been done for all. Okay, I haven't done this task. However, as you are saying that a folder of images can be shared and then detection can be performed, we need to. There are some more commands with the Python to zip and unzip all the folders, and then detection can be done individually, and then they could be saved. There could be some other process. I haven't tried this. Hriday. Yes, yes, Umesh. Okay, 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 okay. See, this is for the first time it happens that it took months for me to crack this. But if you are getting the result with the first time, this is, I'm giving you my time efforts. I am giving you my time efforts which I invested for long time. Basically, we work on JPG files. Okay, as per what I did practice and what I have seen, it works on JPG. Though you can try PNG files also here. Let's see what happens. Okay, just upload a PNG file, give an extension bicycle.png. Okay, and check out what happens. Though because images are having different file formats, it should work. For the general, it works with the PNG, JPG. Yes, Bhagashri. Yes. Okay. Custom. It is custom. Hmm. 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 How to do? Abhi, I'm just coming to the next code, that is custom object detection. Okay, that means you're detecting object as per your choice. Okay, this is something which is already present. Okay, now, okay, so uh, I guess this code clear to you all. Whatever we did, recording has been in the process. Okay, it's been there. I hope this has been clear to you all. Okay, if there are certain errors, nobody. I have already shared the screenshots with you. I have shared the complete code with you. Recording has also been there. Recording has also been there, so you can crack the problem in real time. How we can do with the webcam in a real time? See, uh, let me work with the custom data set also, then we will discuss Arshia. Okay, so I'm going to quit this meeting. Okay, and I will re-mail you another Google Meet link to all. I again mailing you another Google Meet link. We connect on that link and proceed further with the custom object detection. Okay, so I'm quitting this. You also quit. You also quit this meeting. Okay, we'll reconnecting it on another Google Meet link. Okay, because my next project, because of the availability of the space, that is why I have now I'm working on another my Google ID. I'll share you the link again in quickly 5 minutes. You just do connect with me. Okay, you can left this meeting. Okay, we are reconnecting. Okay, okay, okay. Thank you.